Hey everyone, welcome back to our Python beginner tutorial series. Today we're going to be creating an exciting text adventure game. We'll learn about strings, lists, conditionals, and functions, all while having fun. Let's go ahead and dive on in. Remember to make sure that you have Python installed as well as Visual Studio Code or your preferred Python development environment. So let's go ahead and create a new file, and I'm going to call this one text_adventure. .py for our Python file. Go ahead and save it in our Python folder here. And we're going to start off by creating a basic storyline, which allows players to make decisions with their inputs in the console. So let's go ahead and define an intro. And this is how we can start off our game. We're going to have our brackets here be completely empty. We're not passing or requiring any information within these parameters this time. So let's go ahead and print a couple messages to them. We'll say you find yourself in a dark forest, 2 paths lie ahead. Go ahead and print another line here. Do you go left or right? Wonderful. Now let's track their choice by tracking a variable here, and we'll say that the choice is the input. And this is going to be prompting them to either type left or now let's use our conditionals in the form of our if statements to say, okay, if the user chooses to go left, I want this to happen. Well, we'll send them down the left path. And I'm going to reference a function we haven't created yet. We'll be creating it momentarily. And we'll say else if the choice equals the right, they'll go down the right path. And we'll do a final else just in case they spell right or left wrong, or they give an incorrect answer, and say print invalid choice. Please type left or right. And I'm using these apostrophes just to make it more clear this is exactly what they're supposed to be typing in our program. And then we're actually going to call upon our intro function to boot them back to the beginning. Now, the only thing is right now, if we were to kind of play this program, we would probably get a really weird error if we were trying to type in right with all capitals. Currently, right now, our user needs to type it in all lowercase, right? Is there a way that we can circumvent this? Yes. So in the choices here, we can actually use the dot lower empty brackets, and that's going to take the user's input. So let's say they typed right like this with different levels of capitals and lowercase. It's going to treat it as if it was typed like this. It's going to take their text, and for the sake of our program, it's going to treat it all as lowercase. This makes it so no matter how the user types it, as long as they spell it correctly, it's going to go through. So dot lower ensures that the input is case insensitive rather than being case sensitive. And we've also introduced these basic conditionals early in our code. So now let's create some game paths with functions as well as progression. So we're going to define what happens when the user chooses each path, including further decisions. So let's create a couple more lines, and we'll go ahead and define the left underscore path. So something I want to point out right now is you can kind of see on the left side here, we have these lines that are connected all the way down from when we started the intro, went through our if-else statements, and now when we're defining the left path as well. So this is an issue because this means that the code is being nested within the function of the intro. We don't want this to be the case. We want our functions to be independently created. In other coding languages, we use like an opening brace or perhaps a closing brace. In Python, we need to make sure that our indentations are correct. And you can see once I've deleted those indentations, the lines have been broken, and this function is on its own. We don't want it nested within that intro, or it'll cause some errors. It's its own separate function, and as we write code, you'll see that we create our own little kind of lines of nest for the specific scenario and function. Okay, now let's go ahead and print what's the message going to be to the user. Let's say they meet a friendly wizard who gives them a sword, like in The Legend of Zelda. Then we'll print some more options for them. So in this case, do you want to explore the castle or return Let's then get their choice once more. And this is going to equal the input. So we can say type castle or home. Just like with before, let's go ahead and treat it as .lower. So the user can input whatever they like with capitalization, as long as they spell it right, and get the correct results. Let's handle those different choices. So if the first one is indeed castle, they can go to the explore underscore castle function. And you can kind of see how this can build upon itself. And else if the choice equals home, they can play again. They're kind of restarting the game here. And actually, let's provide them with a message first saying you safely returned home with your new sword. Okay, and just like with above, let's also handle if they type something that's not one of our prompts. So use our final else here and print invalid choice. Please select castle or home. And because we don't want them to repeat the entire game, let's just boot them back to the left path. This way, if they type something wrong, they get to create the choice again instead of restarting from scratch. Okay, and let's go ahead and define our right path. And you'll see again, we're still nested within the left path. These are two separate functions. So let's go ahead and backspace out of that nest there. Add our colon here, and let's say on the right path they encounter a dragon. And this dragon, they capture you. Then let's give them some choices. You must clean the dragon's lair or try to escape. Go ahead and create our choice here. It's going to be the input. Type clean or escape. Handle our choices with our if statements. If choice is clean, and tell them you chose to clean the dragon's lair for the next month as payment for freedom. And in this case, they kind of lost, so we'll prompt them to play again. We'll do our else if here. We chose escape. We can print that they avoided the dragon and managed to escape their lair. And then we can boot them to, the escaping of the dragon scenario. And we'll handle it with one more else, in the case of they didn't type it correctly, invalid. Please type clean or escape. And then we can boot them back to the right path, just so they don't get locked out again. Okay, we can define the next steps of the adventure, and you can choose to go as far as you'd like with this choose your own adventure book. You can kind of see how many different choices we can have. Now we can really use conditionals as well as user input to make these decisions. You can even provide them with multiple choices. I'm just doing 2, maybe do 3 or 4 using different else if statements. So let's go ahead and finish up by defining the explore castle. If you want to make sure you don't have spelling mistakes, you can always copy and paste from when you first initiated them. Oh, and we want to make sure that this is not nested within the right path. In the case they explore the castle, inside the castle, you find glorious loot, and they can go ahead and play again afterwards. They beat the game as far as I'm concerned, and we'll also do the case of the escaping of the dragon. Print to the users that you safely return home with a new story to share. And they can go ahead and also play again. Make sure that this one is not nested. Perfect. We've clearly defined each decision path using functions. These functions help keep our code clean and organized, as well as demonstrate progression chaining throughout our story. Oh, and I forgot to put choice here on line 41, else if the choice equals escape. There we go. Okay, the last kind of error we have is play again doesn't exist. So let's go ahead and add that replayability to our app. Again, make sure we're not nested in the previous function. Play underscore again. Create a choice with the input. We can ask, do you want to play again? And then we can provide them with a yes or no. If the choice equals yes, actually instead of y and n, let's actually type that out. It's no, a little more clear. Then we can boot them back to the intro. Else if the choice is no, we can print them a message saying no thanks for playing, goodbye. And the else statement finally would be print, please type yes or no. So even though we're kind of using this else to kind of handle our situations where people have typed things in incorrectly, we still need to make sure that we're doing it for error handling. Speaking of error handling, let's go ahead and double check our choices and make sure they all have lower. I know I got a little bit lazy and started going a little bit quickly. So let's check that choice now has lower, and we'll do this one with lower as well. Otherwise, if they have the incorrect cases, we're gonna not be able to play our game. And finally, now that we've created all these functions, let's go ahead and start our program by just calling upon the intro itself. This way, when we're defining these functions, they're not actually running until they're being called upon. So we kind of defined everything, and at the very bottom, once it's all been defined, we'll call upon the first function intro, which should allow our gameplay chaining. Let's go ahead and test out this game. All right, we find ourselves in a dark forest. 2 paths lie ahead. We're gonna go left or right. Let's go ahead and go right. We encounter a dragon. They capture you. You must clean the dragon's lair to escape. Type clean or escape. Let's go ahead and escape the dragon. We safely return home with a new story to share. Do you want to play again? Yes or no? We're also going to go ahead and just quickly test that if we type in yes with all capitals, it still works. We have started the game once more. Let's go left this time. And let's go to the castle. Let's do it in all caps so we know it works. Do you want to play again? No. Thanks for playing. Goodbye. So something we talked about in this video are lists. Lists allow us to hold different organized items. You may have heard of the term array when working with coding before, and this allows us to kind of track as well as index different objects or items. Let's add a list to track our users' inventory as they play the game. So at the very top of our program, let's go ahead and give our list a name. I'm going to call this one inventory. We're going to use the equal sign, and we're going to establish what that list holds. So within these kind of square brackets here, this is where everything within our inventory will go. So you can choose to even start off your adventure with something in their inventory, maybe some health potions or a map or something. I'm going to make sure that mine is blank. So I have nothing within this list. Well, how about when we're playing our game and we encounter the wizard who gives us a powerful sword? How would we add that sword to our list, or in this case, our inventory? Well, we would reference the list name, so in this case, inventory. We would then use the period, and we would use append. And this allows us to add different things to our list. Add something to the list, append. Let's go ahead and add a string to our list, which is the powerful sword. And then afterwards, let's go ahead and print their inventory. So we'll go ahead and create a print statement, and we'll say your inventory. And then outside of the string, after the quotation marks, but still within the brackets, we'll add a comma. We'll then reference the inventory. So you can choose to, maybe when the dragon captures and we clean, maybe you get some loot of a broom or something like that. Even when you find the treasure, you're a hero, you can use this to update and change items within a list. All right, let's run our program one more time. So in this case, we're going to be going left to the wizard. Go ahead and type left. You can see that our inventory has the powerful sword now. So we have added that to our list. And that's how we can manage lists within Python. There's a lot of different things you can do with these lists or arrays. And this is just simply scratching the surface, but try playing around with them and see what you can figure out on your own. However, in our data visualization, we'll be going through dictionaries and lists a little bit more in depth. Today, we built a simple but interactive adventure game. You've learned about structuring code with functions, decision making with conditionals, and engaging users through interactive storytelling, as well as learning how to add items to a list. Fantastic work. Next, we'll explore automation in Python, which is actually the whole reason I personally got into Python. So we'll create something where you'll be able to actually organize your files instead of a purely console application. So that'll be really fun. Please subscribe and leave your comments below. Or if you have any questions, feel free to ask. Remember, dream big, code bigger, and we'll see you in the next one.